Here we're going to solve this quadratic equation. A quadratic equation is one with an x squared as its highest degree exponent. One of the best ways to solve a quadratic equation is to set it. Here I'm going to subtract and add certain terms to get the right side equal to 0. You can get either side equal to 0. The right is usually the most convenient. Combining like terms gives us a 0 on one side and a polynomial on the other. The next thing I like to do is calculate what's called the discriminant, which depends on the values of a, b, and c in the polynomial, which of course are the coefficients on the left side of the equation. So in this case, a is 1, b is -4, and c is -3. Plugging those values in and doing PEMDAS lead us to the value of the discriminant, which we need because the quadratic formula, which is going to give us the solutions to our original problem, require that we know the value of the discriminant. Plugging in 28 for D and also plugging in A and B from step 1 lead us to an expression that will give us the two answers to this problem. First, it's worth noting that radical 28 simplifies to 2 radical 7. Then, what we can do with the plus or minus is split it up into two roots, one with a plus and one with a minus. A root, by the way, is another word for a solution to an equation. So, now we cannot combine the terms in the numerator because they're not alike, either numerator for that matter. But what we can do is to divide both of them by the denominator. Since the denominator is 2, let's look at the first one on the left. I can split that denominator into a common denominator of 2 fractions. This will allow me to simplify the problem. 4 divided by 2 is 2, and in the right fraction, 2 times radical 7 over 2 is just radical 7. After all, if you take radical 7, or any number, and multiply by 2 and then divide by 2, you will get the original number back. The same thing happens for the solution with the minus, and now we have the two solutions to this equation.